Good morning, everybody. Today we will start a new topic, exception handling. Exception handling is not a standard part of object-oriented programming languages, but almost all of them, implements this technique. It's a way of organizing your error handling mechanisms in a way that it is more standard, it is more understandable by the other programmers, and it is supposed to be helpful when you write your programs. Okay, let's see one pseudo example of how we write programs previously. This is what we did, right? This is what we said. We said that, okay, we perform a task. Okay, let's try to give some examples. Okay, let's say we try to open a file using the open function, right? File opening function. And then we check if the file opening is successful. I mean, we may not know that if the file is already there or it is writable or etc. Okay, check if file is open. So there is an if statement there, right? There is an if statement there. Or I would open a file and I would check if the file opening is successful. Then maybe I will do allocate some memory, allocate memory, and then check if the allocation is successful, etc. This is what we do, right? So actually maybe I should do this. These green parts is what I want. This is what I want. Open a file, allocate memory, maybe open a network connection. Okay, these are the things that I like to do, but I know that in real life, things may not go as planned. Sometimes there would be errors. For example, I like to open a file. The file is not on the desk. Or I like to open a file for writing, but it looks like I am trying to open a file on a CD which is not writable. So I need to check it, right? I need to check if the file is open. If there is an error case, then maybe I will have to terminate my program. I like to allocate memory, but I need to check if the memory is allocated, if the return value is null or not. Okay. Open a network connection. If I like to check if I am really connected, right? I need to check it, because in the network world, I don't know, maybe my connection is dropped. It is not successful. Something happened. So what I am trying to say here is that usually this is what we do. We like to do the green stuff, and in a perfect world, everything happens okay. Everything goes as planned. But in the real world, I have to be careful about the errors. Okay, errors might happen. So in this picture, I have to intermix my logic, my programming logic, okay, of perfect things, okay, nice things to happen, and the bad things to happen too. In the real life, I have to deal with all of them at the same time. Okay, so we don't like this kind of programming actually. I mean, up to now we have been doing this all the time. We do something and we check if it is okay. We do something and we check if it is okay. We don't like this happening. Why? Because this is intermixing, okay, error handling and the regular program flow in the same place. So exceptions are a mechanism to prevent this kind of programming. They say that you are going to write your program in a way that, okay, You're gonna write your program in a way that okay, all the green stuff that I have drawn a few minutes ago here, like that. Okay, let me see. Like, okay, open file, allocate memory, connect network. Okay, all the green stuff are put one after the other. Okay, you don't think about the errors when you are writing your regular code. You think that nothing will bad happen, and you do this in a try block. Try is a new C++ keyword for you. Okay, then after that I write my catch block. In the catch block you would say what kind of errors you would expect, exceptions. It's like function parameters. Okay, you would say, okay, you would put your error handling code in here, these stuff like, okay, file error. What would you like to do with the file error? Maybe you're gonna print a message and terminate the program. Maybe you will do something. Okay, this is memory error, this is network error. So here is the main structure of your program. You will write your nice code in the try part, and you will write your error handling code in the catch part. So you're gonna write try catch blocks. Okay, you're gonna write try catch blocks. Of course, when a bad thing happens in your own code, there should be one way of telling that, okay, there is something bad happened, and we are gonna show you how it is done. That's the idea of exceptions. Okay, that's the idea of exceptions. We like to go from here to there. Okay, good. So let me go back to the beginning of the slides, and let's start talking about this. By the way, these slides are again from some other book. I don't like how our book discusses exceptions at all. It is not saying anything wrong, but it starts very bad with a bad example. I don't like that example at all. Okay, maybe we should start with a better example. That's why I like this this discussion from the other book better. Okay, so exceptions, they are a way of indicating problems that occur. Okay, of course, exception, as the name implies, they are exceptions, right? They don't happen often. Okay, they happen very, very rarely, and they are not the part of the main program execution. Okay, main program execution. They happen very rarely. They happen once in a while, but if it happens, it's a bad thing for our regular program execution. An exception handling means that I need to handle this exception. I cannot say that something bad happened and I don't care. No, it's your program and you will have to handle it. Okay, you would allow a program to continue execute it, or you notify your user, or you terminate the program. Okay, and the main idea of exception handling is this: we like to make our programs robust and fault tolerant. That's the idea of exceptions, fault tolerancy. Okay, so it's a way of writing programs so that even there is a problem with the execution of our program, it will not crash, it will not do even worse things, and most of the time we will be able to recover. Okay, so and it's standard. What do we mean by standard? Everybody understands what we are doing when they look at our code. Okay, and as we said, its fault tolerance is increasing. Okay, and exception handling is a standard way of processing errors. Okay, so this is especially important if somebody else is reading your code, modifying your code, or you are working with a team of people. Okay, so exception handling, you remove your error handling code from the execution of main line. Your main execution thinks that everything is going to be fine. When I open a file, it will be opened. When I allocate memory, it will be allocated. When I divide two numbers, A over B, B never will be 0. Okay, etc. So that's the main execution, but things can go wrong. In that case, we removed our error handling code. We need to write error handling code, and we are going to remove that error handling code from the main line. Okay, good. So most of the time we are going to use this class exception. It is part of the C++ standard library. Okay, it is going to be a standard C++ base class for all exceptions. I didn't say what exception is yet, but you're gonna see it. It's just simple. The name is just class name exception, but the main idea here is exception handling, and you're gonna say it. It's not difficult. It's not difficult to understand. But this class exception has a virtual function named what. What is the virtual function of this class exception? Okay, and when you call this function what, it returns a string actually, and that string tells you what happened. Okay, let's see the example. Example is, let me show you the main function first. This is our main function. It's going to be a very stupid main function. We are going to just divide two numbers, that's it. Okay, so number 1, number 2, and result. And I ask the user to enter two integers. Okay, and I get the two integers from the keyboard standard input. And I call this function named quotient. Okay, this quotient will divide number 1 by number 2, and I will print this out. Okay, and I will do this. Okay, I will do this until this cin returns. So if y, okay, so if cin returns this thing, if this thing returns control D, I guess, end of file, yes, end of file. If somebody hits control D, then this loop will end. But here is the code. The code says that I will divide number 1 by number 2. This is a function. Okay, and I will print the result. So this quotient function just takes two parameters and it divides number 1 by number 2 and returns the result. That's it. But the thing is that here we need to be careful. Why? Because if number 2, both of them are integers, right? Both of them are integers. If number 2 is 0, if number 2 is 0, then this division is not valid, right? There is a division by 0 error. But it looks like I don't check it, right? I don't check if the number 2 is 0. So usually what we do is, before sending these two numbers to this function, usually we check if the number 2 is 0, then you will say that, no, this is not valid. I don't like this. I am going to terminate this program, or maybe you should enter another value, etc. Right? But here, as you see, we don't write that. Instead, we say that in this try block, we call this function, we get the result and we print it. Okay, and we say that enter two integers again, go back top of the loop and do it again. In case an error occurs, in case this quotient function is in trouble, when number 2 is 0, then this function throws an exception. That's the term, throwing an exception. Okay? When that function throws an exception, this catch block catches it. Okay? So this part of the code is my green code. This part of the code is the red code. It's the error part. So if this function throws an exception, that means that that function is in trouble. It detected an error. I will catch that error. So it looks like that function is throwing an exception of type divide by 0 exception. See, here it is. Divide by 0 exception. I catch that exception. It looks like I am catching it with a reference. Okay. And I catch that exception. I say that divide by 0 exception, this one dot what? Remember that exception class? That exception class has a virtual function named what? And that's why I get this using a reference. Remember how we called the virtual functions to use the polymorphism? Either we use the base class's pointer and the virtual function, or the base class's reference. Okay? Or in this case, I am using the class itself, the reference. Divide by 0 exception dot what? Okay, and this will print out what is wrong. Okay, I still did not look at the implementation of the quotient function, and we are going to see it in a few minutes. Okay, as you see, the structure of this code is very similar to what I told you before. Green part is up, and it doesn't care about errors, but red part deals with the errors that can happen. Okay, the errors that can happen. Okay, any questions so far? Before I look at the implementation of the quotient function. Okay, no questions? Okay, let's look at this implementation of the quotient. Quotient is here. Okay, quotient is here. It says that I will take two numbers, integers. If the denominator is 0, numerator and denominator, if denominator is 0, I will throw an exception of type divide by 0 exception. That's it. Okay. So throw is something that terminates this function. After this line 17, this function is terminated. It's like return. Okay. It's like return, but it is not return actually. Okay. Because this function returns only a double. But if there is an error with this function, it returns, okay, it returns a double if there is no error. If there is a problem with this function, then it will throw an exception. By the way, you can throw anything that you like. This one throws an object of this class, but I could say throw 10. I can throw an integer, or I could say throw a money object, doesn't matter. Money 10. Doesn't make any sense, but I mean, you could throw anything that you like. Usually we throw objects of classes that derive from class exception. And this divide by 0 exception derives from class exception. Okay, I throw this one, And after line 17, if I hit line 17, this function is terminated, but it is not terminated regularly, okay? It is terminated exceptionally. And if somebody calls this function in a try loop, and there has to be a catch in a try block, and there has to be a catch block after the try block, I will catch that exception, I will handle it, and after that I will continue. Okay, after I catch this, okay, this line 38, when I call this quotient, if everything is fine, I will get my result and I will continue. If there is a problem with this function, it will throw an exception and this try block will be terminated and my control will pass to catch, and catch will catch that exception. Because the thrown exception is of type divide by 0 exception, then I will catch it and I will handle it. After that, I will continue with the rest of the execution with line 49. Okay. Okay. So that's the implementation of the function quotient, and the rest is very simple. I just divide numerator by denominator. Of course, I don't want this to be a integer division, so I convert my numerator to a double by typecasting, static casting. So this is a double division, and I return it. Let's look at this divide by 0.h. Inside that divide by 0.h, I have the class definition of divide by 0 exception. It is very simple. Divide by 0 exception, okay, derives from runtime error. Runtime error is a standard C++ exception class, okay. And what I do here is that it's very simple actually. I just write my constructor, divide by 0 exception, okay. I don't know why they did it that way. This may not even compile, but of course I don't need this part, right? Because I am only in the class, okay. Divide by 0 exception, I am calling the base classes constructor runtime error, and this is attempting to divide by 0. This is my message when they call the what function of the divide by 0 exception objects. Okay, that's it. This is the header file, divide by 0 exception.h. Okay, good. Let me give you another example from our book. The final example in our book is a good example actually, but previously the examples that it gives are not good, okay. So I have a function named getHighScore, okay, and this is the implementation of highScore. Okay, getHighScore is a function. It returns the high score in score.txt file. It looks like it's going to open a file named score.txt, and it will scan that file, and it will find the highest score, and it will return it. So okay, good. I have an if stream input file stream object. The high score is -1. I open the file, and this is my regular way of writing the programs without exception handling. So the get high score function is exactly like that, okay. I open the file. If file is not opened, then I print an error message and I return -1. Okay, and then integer num, and I will read those numbers one by one in a while loop, and I close my function file, and I return the high score. And in my main function, I call this, okay. Do you see any problems with this implementation? Main function? Do you see any? Of course, this will compile and run, but do you see any logic errors with this program? Do you see any logic errors with this program? Where is the infinite loop, Mustafa? Where is the infinite loop? You mean this while loop? No, there is no infinite loop, because when it reaches the end of the file, it will return a false and it will terminate. Yeah, Ahmet, exactly. Okay. So if the file cannot be opened, it will return a -1, this high score, and I will print this high score is something something something. Okay. High score is so I need to put maybe if high score is not okay -1, then I will do this, because this high score sometimes can return -1. -1 is not a meaningful thing, so I need to be careful about what it returns. Exactly, I mean exactly what I have written before. Remember this? Remember what I have written before? Where is it? Yeah. Do something and check for the errors. Do something, check for the errors. And this is what I am doing here. Here, I am doing something, I am checking for the errors. I am doing something, I am checking for the errors. And this makes it complicated to write these kind of programs. I have to always keep in mind that error might occur, and then I need to be careful, and etc. Right? So the book says that don't write the program like that. Okay, don't write the program like that. You get high score. Write get high score function in a way that it throws an exception if something bad happens. Okay, so this one is going to throw an object of this file IO error. Okay, the better thing would have been the exactly the same as this one. Better thing would have been, can I copy it from here? Can I do that? Okay, public runtime error, I will do that. Okay. Okay, better thing would have been like this one. Okay. So get high score the get high score function says that I am a function that will not take any parameters, and if the things go as planned, I will return an integer, and you are going to use this integer. Okay. If the things go bad, I may throw an exception of type file IO error, like this one. Okay. This is a new syntax here. This is called a throw list. Okay, this is called a throw list. So we never did anything like this before. We are defining a function. I mean, for us, function means something like that. Okay, a function takes parameters and returns something, and it has a name. This one doesn't take any parameters and it returns something and it has a name. Yeah, everything is fine. But now we are saying that this function might throw exceptions. Okay, it looks like this function can throw only one exception. File IO error is the only exception. Okay, and I can throw that exception. That's nice. And whoever is seeing this header, they are gonna write their code accordingly. Okay, let's see how the code is written. It says that in a try block, I call this get high score function, and as if nothing bad can happen, I am just printing the high score, and there is no problem. In case that this get high score function throws an exception, it will be caught by this catch statement, and I will print the statement out. Okay, so let's look at the implementation of that get high score. It is very simple. Our stream fopen. If I can open this file, then I'm fine. If I cannot open it, I will throw an exception, and I will terminate my function here. I am terminating my function not in a regular way, but in an unexpected way, in an exceptional way. Okay, in an exceptional way. So I will just throw a file IO error. If I throw this one, this function is terminated. If I don't throw it, if the file is opened, then I will read all of those numbers one by one. Okay, and I find the maximum one, and I will return the maximum one. But before that, I will close this function. Okay. So that's basically it. The idea of exceptions are this. You define an exception class usually, but you don't have to, as I said before, you don't have to. And when you are doing that, you usually do file IO error. Okay, I am writing the constructor runtime error, and the implementation is just like that. Okay, cannot open file. That's it. I'm calling the base classes constructor, and that's it. And get high score is a function that will return an integer under normal conditions. But sometimes, if there is something wrong, if it cannot open the high score file, it will throw an exception. And whoever is calling this function should be careful, because that function might throw an exception. And this is how you throw an exception from a function. And when you are writing your client code, you always be careful, because this function most of the time returns an integer, but sometimes it returns an exception, and this is how you catch your exception. By the way, let's catch this exception. Okay, and could not open the scores file, and let's print out what this exception returns. Okay, remember, this file IO error derives from runtime error. Okay, and the runtime error has a function named what, and what prints whatever this string tells it. Okay, so Anand Mert has a question. Should we implement a class for all type of exceptions? Usually, yes. I mean, if the errors are different, yeah. For each type of error, you should make a new class. Okay, you should implement a new class. But your class definitions are usually as simple as this. But in theory, I mean, as the syntax of the C++ allows, you don't have to declare new classes. Okay, you may throw anything that you like. You may throw integers, you may throw doubles, you may throw many objects. But the nice thing that would be allowable is, the better thing is, usually we throw objects of classes that derive from class exception. Okay, any other questions? We understand it, right? I mean, the idea is let's separate our regular mainline code from the error code. We don't like writing error code, but we have to, okay? So somebody has to write it. Instead of intermixing our regular code and the error code, exception handling says that put the regular code in the try sections and put the error handling code in the catch sections. So whoever is studying this code, they will understand that this part is the nice code. This part is the bad code that nobody likes to write, but somebody has to write it. Okay? Somebody has to write it. This is different from this type of code, okay? In this case, this is the nice code. This is the code that I have to write, but I don't like to write. They are mixed together. They are mixed together. Mehmet abi has a question. Can we implement two throw statements in line 16? Line 16. Where is line 16? Yes. If you can throw a file IO error and let's say another one memory error. You may throw as many throws as you like from a function. Of course, this one throws a file IO error. Maybe you're gonna do, okay, let's say you are going to allocate an okay, new int, let's say this much, very big number. Okay, what should I do here? It is if IP is null PTR, right? Then what am I gonna do? I am going to throw, I don't know what kind of, okay, what was the, okay, memory error. I did not define this yet, but I am going to just throw memory error. Okay. Now I handled this error too, but whoever is writing some code that uses this high score should be careful. Why? Because this function now can throw two errors, two exceptions. File IO error, or it can throw memory error, right? Let's write the code for that one. Catch. Okay. Catch memory error here. Okay. Maybe not enough memory. Okay. So you can this list can be extended as much as possible, as much as necessary. Okay. So as a single function can throw more than one exceptions. Okay, good. Any other questions? Any other questions? Okay, in that case, if there are no questions, let me go back to my slides. And if there are any places that I did not talk about. Okay, class exception is here. Let me show you the hierarchy for the class exception. Where is my hierarchy for the class exception? I will show you here. Okay. So this is the class exception. It has a virtual function named what. is the virtual function, and runtime error and logic error. Runtime error is the error class that I have derived my file IO error. Remember, that's what I did. And these are the stuff. For example, this bad alloc is thrown by the operator new. Okay, operator new. There are two ways of using operator new. Okay, if you use that operator new, and if it is not successful, it may return a null pointer. But if you like, it can throw an exception too. And I will show you how. Okay, so these are some of the standard exceptions, but if you like, you may throw any of them. Okay, you may say that I am throwing a runtime error exception. I am throwing a bad exception, bad type ID, or bad cast exception, etc. Okay, but usually we pick one of them and we derive our exception class for that. Okay, good. And usually when you look at the documentation of a C++ function, you will see what kind of exception it throws. Okay, you will see what kind of exceptions it throws. For example, this out of range, let's see who throws that out of range exceptions. I'm going to, okay, C++ out of, how did I, okay, out of range, okay, out of, where is this? Oh, this one, I found it. Okay, out of range. Okay, this is standard class out of range. It comes from logic error, and it looks like, okay, here is it. Here it is. See, remember what I say at the beginning of the semester, maybe there are two element access functions of vector. One is in the index square bracket index operator. The other one is at. What is the difference? At checks the range. If the range is out of the bounds, then it will throw an exception. See, this function at, the standard vector at, okay, will throw an exception. Why? Because my vector has 10 elements in it, but I am trying to access the element number 20. In that case, this at is going to throw an exception, and that exception is out of range. And I get that out of range, and I will print whatever it says. Okay, so it looks like out of range error, vector m range check is the message. Okay, good, out of range. How about this domain error, length error, invalid argument? Let's see let's see an example for that invalid argument thing. Invalid argument. Okay, bit set. There is a bit set class. I think I asked you last time. Okay, this is a templated class, right? Can anybody guess what this bit set does? What's a bit set? It's like a vector, or it's like a templated set class, but it says it's a bit set. It looks like it's a class for representing binary numbers. If the numbers are binary, then all the elements should be zeros and ones, right? This one says that I have a bit set of size 5 or length 5. And I asked you last time, just look up what it means to have a integer as the argument for a template. It looks like it is using a fixed number as the template parameter, not like integer or double or etc. But and this one says that I am giving you a string of 0, 1, 2, 3, 4, but as a bit set it should be either zeros or ones. I have 2, 3, 4. Okay. When you run this, it will throw a invalid argument exception. That's what the definition is. Okay. Let's go to the bit set definition of bit set. Let me find that bit set. Where is bit set? Okay, I think I
Teacher,
will.
that 5 is the length, right?
Say that again.
The 5 is the length of the bit set, right?
To do that, let's look at the definition of bit set. Let's see what it says. Yes, that's what my guess is. And it was your task to learn why we preferred. I mean, why don't we? You would have said. Let me edit this. Okay. Edit and run. I didn't know that this was available here. It's so convenient. So why don't I make this a constructor parameter instead of making it like this? Okay. Anybody has any ideas? Why would I make this a template parameter instead of a constructor parameter? Okay, that was part of your actually exercise. You were supposed to learn it.
So it use vectors, maybe.
But it is not. Bit set is not a vector. I don't know. Let's look at the documentation. Bit set is no. Oh, okay. Bit set is here. No hyphens. So bit says that, okay, size tn. Okay, bit set stores bits, array of bool elements, but optimized for space allocation. So it's actually maybe a vector. I don't know. So the bit solution can be accessed individually, being able to construct it from a converted for integer types and binary strings. The size of bit set is. So this is the answer to my question. The size of bit set is fixed at compile time. So what does that mean? It is not a constructor parameter, it's a compile time parameter. So constructor doesn't spend any time during the construction of this object. Okay, everything is determined during the compile time, so it is more efficient that way. Okay, let's look at the constructor of this bit set. Constructor of the bit set is here. Okay, it says that there is a constructor that doesn't take any parameters. There is a constructor that takes a long integer, and there is a constructor that takes a string. Okay, that takes a string. And the parameters are explained here, str, and there should be, okay, exception. Neither the default constructor nor the constructor from integer throw exception. The other constructor causes no side effects. So where is the exception then? Exception, okay, here it is. Okay. Out of range exception is thrown for the third constructor. Where is the other exception? I'm trying to find. Where is the bad parameter exception? Is it in the C++ 11 documentation? Out of range. I did not find it. It was bad parameter exception, right? Where is it? Invalid argument, sorry. I don't find it. So this documentation and that code is not compatible with each other. Maybe they forgot to put it in. So usually, but we have other exceptions here, okay? You would have in your documentation, you would define what kind of exceptions you throw when something happens, okay? This one says that for the position value of the constructor that takes a string, if it is out of range, then you will get an out of range exception. Okay. Good. So this all came from the question, should we implement a class for all type of exceptions? If the exceptions that you need is not one of them, okay, overflow, underflow, okay, out of range, invalid argument, then yes, you would do that. Okay. For example, for the divide by zero exception, maybe I could have thrown this invalid argument exception. Why? Because zero is not a valid argument for a function of type quotient, right? Quotient function should not be called with a denominator of zero. Okay, so let me go to the beginning again, and let's continue from that point. Okay, so I did that and I looked at this. Okay, so try blocks. You always call your functions that may throw an exception within the try blocks. Okay, you have a try block. It starts with a curly bracket, ends with a curly bracket, and you put your nice green code in it. And you assume that no error happens when you execute these lines. Line 1 will be executed, then 2, then 3, then 4, then 5. Nothing will happen. You don't make any error checks. You don't say, if something happens, do this. If that thing happens, that. So whatever happens is the regular part of the algorithm. You don't expect any errors inside this. But in real life, of course, we expect there would be errors, right? What we expect is there would be errors. That's why after that, we write our catch block. Catch block takes these parameters, and again, error handling, red lines, and there could be more than one catch block. Okay, good. But it looks like I'm out of time. Let me take 10 minutes of break. After that, we will continue with the rest. Okay, so let's be here around 11:37. Ben de alışacağız zaten.
Yani ben de şeyleri yapıyorum. Ya dediğim işte o adamlara yükleniyor. Onlar gelişiyor mesela daha yavaş. Ama ne yapıyorsun? Ama ne yapıyorsun? Sen ne taraftan anlatıyorsun? Yok sen de Gökçe'de kim avlayansın? Halit var. Laf öğrenmemiz. Nasıl hala kendini hala yani bize söylemeden bize söylemeden bir şey farklı bilmem ne oluyor. Tamam, bir dakika. Kesin vardı ama ben de okuyayım. Kesin olduğunu biliyorum.
Olunca mesela sonucu anlık söyledi değil mi? Anladın değil mi? Yönetici daire başkanı olmuş.
Bilgisayarın daire başkanı olmayacak. Murat Boz'un aynı soru aynı çıktı ortaya. Biz de adamdan 204 şey istedik. Kadar istedik.
Aslında o geldiği zaman her şey giderken bizim onu yapmamız lazım.
Yok öyle bir şey. Ama siz bitmiş. Bize haber mi geldi? Haber gazeteci yapar. Bir şey hocam. O da gitti.
Değil mi? Adam İbrahim Hoca'dan bir eski de var. Araştırma görevlisi olarak. Hocam tarih diyor, tarih.
Buyurun. Bitmiş değil mi? Ali Aydın'ın oraya kurtulduk mu Ali Aydın'ın? Değil mi? Ha. Şey adı ne?
Tarih başında değil mi zaten?
Şey var.
Burada sevgili tarih başında aynı şey değil mi?
Şey var. Şey vermişlerdi. Yapım vermişlerdi. Yok.
Ben de kim var?
Nadide gene. Hocam biz nasıl nadide gittiğini nadide mi yani?
Yani yeni nadide geçti, eski nadide geldi. O yaşantısını da sen bilirsin mi?
Peki hala benim benden hani onu
Biliyor mu hala? Öğrenci var.
Valla 60'lardan artık adam. Gelir. Cuma günü saat 4.55'te gelir. Tam böyle ve inanla beklerim.
Şeyler daire başkanlığına yolunda güzel çift oldu. Yani bir kütüphanede şey oldu. Daire başkanlığı.
Bu Ali Aydın'ın kırtasaylık öğrenci ya adam her şeyi bize sallıyor ya. Hiç iş yaptırmıyor. Fatma. Ne ya?
Şey yapmak olabilir.
Şey vardı da. Şermin Hanım vardı. Öğrencilerden temel bilmiyor.
Ama kadrosu hala gelmiyor. Kalıyor. Temel günlerde sekreter kalıyor. Sonuç olarak ben aslında sadece tanışıyorum.
Murat bitti hocam. Hacer bitti, Murat bitti. Başla. Ama sertifikadan verin. Yok, bakma bir şey değil. Bakma bir şey istiyor mu? Ya, Zeynep'den bakma bir şey yok. Ne alakası? Bakma bir şey yok. Ya, o kadar da falan. Ne diyorsun? Altta bakma ne alakası var?
Yes, Hussein, we have a final block in C++. In C++11, they have added it, and I will show you examples of it. So try blocks, they will work this way, and you cannot, you don't write a try block without a catch block. That doesn't make any sense. Okay, you should write each try block should be followed by a catch block. Okay. So exceptions may surface through explicitly mentioned code in a try block. Okay. This is an example of a try block that you should never write. This is an example of a try block that you should never write. And that's exactly from the book. From the book. That's why I don't like this book. Okay, for this chapter 18. I have a try block here between line 11 and 25, and I have a simple main function. That's it. I don't have anything else. Okay. Inside this try block, I have two integers, donuts and milks. Donuts and milk. Okay. If milk is less than 0, it throws an integer. And this integer is called in the same function. This should never be written, okay? This is a very bad usage of exceptions. Don't do it this way, okay? Because this doesn't make any sense. What is the point of exceptions? You would separate your regular execution from the error handling, right? This is kind of, again, intermixing between them. This is not a very good code. You don't throw an exception and you catch it in the same function, okay? You are not supposed to write code like that, but it is possible. That's why I am showing it to you, okay? So exceptions may surface through explicitly mentioned code in a try block through calls to other functions. So in a try code, this function may throw an exception, this function may throw an exception, or you may throw an exception inside the try block itself, which should not be done normally under normal conditions. Okay, so catch handles are like functions, right? They are receiving parameters, okay, and they say that I will catch any errors, any exceptions that I thrown inside the try block, okay, with these parameters. If the parameters match, then I will catch it. If the parameters don't match, then I won't catch it. Cheval has a question. For invalid input, can't we do a loop that wants an input from user? You are saying that invalid input. Well, I mean, it's your decision, Cheval. I mean, for some code, let's say, let's say in a while loop, in a while loop, while true, you might say that try this, okay? Try this, get values from the user and use values. Catch exception reference, okay? In the catch block, you might say cout, okay, enter valid. You might say that. This might be your preference, okay? What is this going to do? This will always get values and use values all the time. If there is a problem with the inputs, I will catch that exception and I will print out a message to the user saying that enter valid values. Or sometimes, maybe, no, I don't want to do that, okay? I want to just see error, and then exit -1. If this is what you want, then you can do that too. That's why we say that this get values function should never make a decision on what's going to happen when the error occurs. It just reports it. It reports an error by throwing an exception, right? It throws an exception. It is the responsibility of the client of this get values function to make the decision on the exception. Okay, so that's why we say that this makes our error handling functions more modular. Okay, it is up to the user. So I write very nice functions. My functions say that I will need these parameters and I will return this. Everything works out okay. If there is a problem with what you have provided, then I will throw an exception. And this is what you're going to do when the exception happens. And it's your responsibility. Okay, so 3 things. My parameters, my return value, and my exceptions. So far, we have only dealt with my parameters and my return value. Now we are adding my exceptions. And we are going to list them very carefully in our documentation. Okay, as I said before, you may have more than one catch block after the try block. A catch block without a try block doesn't make any sense. Okay, so it's an error. So catch should always be following a try. It's like if ... else ... okay. So else doesn't make any sense without an if. Catch doesn't make any sense without a try. Something like that, okay. But the other way of thinking is not correct. I mean, if makes sense without an else, because we use if statements without else statements very often. Okay, it is possible to have if statements without the else statements, but it doesn't make any sense to use a try statement without a catch statement. Try block without a catch block. So when you see a try, there should be a catch, at least one catch. Yeah, when you see a catch, there should be exactly one try. Okay, this is what it says. Okay, each catch handler can have only a single parameter. You cannot, okay, some people say that it's like the parameters, right? When you say catch exception E integer B, etc. No, you can't do that. No, you cannot do that. there should be only one parameter for the catch handler. Okay. Again, it is your decision to continue or stop execution when you get the exception. Okay. So far, in all the examples, when we saw something bad, we terminated our program, right? When we say that, okay, this number is not valid, I am terminating it. This is something and I am not doing this. We terminated the program. No, we don't have to terminate it. We just throw an exception saying that I was not accepting this. Instead of terminating the program, I will throw an exception, and it is up to the customer who makes this call to make the decision, either terminate or continue. Anulmert has a question. Should we define exception class in our header file, or should we have separate exceptions.h for that? Yes. I mean, since it's a separate class, it makes more sense to define it in its own header file. It's like a regular class, right? For regular classes, we like to have header files for each of them. Okay. Throwing an exception is like that I defined. Okay. You may throw anything that you like, as I said before. You may throw constants. You may throw object of any classes that you like. But usually we throw objects of classes in the exception hierarchy. Okay. Remember the exception hierarchy that I have shown some minutes ago. Okay.
Sir, I have a question.
Sure.
I think you said that every try block can have only one catch block, right?
No. Each try block should have at least one catch block. You may have more than one catch blocks. This is my try. Okay, inside try, what do I have? Inside the try, let me show you this. Okay. Where is it? See, this try has two catch blocks. 1, 2. Because there could be two things that can go wrong. Okay, one is file input output error, the other one is memory error. So each try block should have at least one catch block, but you may have more than one. You cannot have a try block without a catch block, or you cannot have a try block without. You cannot have a catch block without a try block. Okay, so for each catch there should be exactly one try, but for each try there should be one or more. Okay.
Okay, thank you.
Okay, so this one is kind of an answer to one of your questions. Who asked this question? I think somebody asked this question. Anil asked this question. Should we implement a class for all type of exceptions? Associating each type of runtime error with an appropriately named exception object improves the program clarity. Okay, so this is what the book, the slide suggests. Okay, so when you are designing your classes, your programs, and you should incorporate your exception handling strategy. Okay, when you say, okay, this is what's going to happen when the things go right, and this is what's going to happen when the things go wrong, and that it should be part of your design process. So you don't add exception handling later when you do after you develop your program. Okay. Some people do this. Okay, some people use exception handling as an alternate form of flow of control. You shouldn't do that, okay? Exceptions are for exceptions only. Okay? You should not do regular flow of control with the exceptions. Exceptions should be done only if you can't do anything else. I don't know what to do now. I mean, I am either going to terminate, okay, or I'm going to do something stupid, okay? So in that case, don't terminate, throw an exception. If the regular flow of control can do something for that case, then do it, okay? So exceptions are expensive. In runtime, exceptions are very, very, very expensive. Are very expensive. So they should be used only for the case of error. If error happens, you don't. If error happens, you don't talk about efficiency anymore. Why? Because it is just errors, right? That's it. By the way, if this program runs without any errors, there is no penalty for this. Okay, so you will get the high score and you will print it, and that's it. There is no penalty for it. So if the things go right, exceptions do not add any runtime overhead for your code. That's why they are efficient too. Let's look at this one. This one says that run the high score. If the high score is not -1, then print it. So I am doing this line for the fun, for the sake of error handling, right? So this is making me slower. In this case, there is no slowing down. Okay, so if you are using the exceptions in a correct way, your programs are going to be faster. Your programs are going to be faster because there is no performance hit related to exceptions if everything goes right. If things go wrong, if there is an error, then you will throw an exception. You will catch the exception. Then that's going to be slow. That's why we say that don't use exceptions to handle regular flow of control. Okay, good. I am going to skip some of these slides because I talked about it. Okay, and this is what I said before. Okay, I will show you another example. Sometimes you catch an exception and you don't know what to do with it. Okay, you catch an exception, but you don't know what to do. You cannot do anything, and you rethrow it. I caught an exception, and maybe I can do a few things, maybe print out a message or close my files, do something like that, but you don't know ultimately what to do next. So you may rethrow that exception. Let me show you an example here. There is a function named throw exception. This is a really stupid function just to show what's happening. When you call this function, it runs a try block, and of course there should be an catch block. It throws an exception. It uses the regular C++ class exception. It throws an exception, and inside the same function it catches it, which should never be done, but for the sake of the educational purposes, it does that. Okay, it catches that exception, and it says that exception handled in function throw exception, but I am going to rethrow that exception. Okay, so see, this is different. This one says that it doesn't take any parameters. I am throwing the same exception that I have code. Okay.
Sir, can I ask a question?
Sure.
Is it possible for exceptions to perform calling, backtracing? For example, throw exception catches an error, an exception, and it wants to throw another exception what it called before. For example, main function. Is it possible?
Yeah, sure. Yeah, I mean, because the catch block is a regular C++ code block. Whatever you can do inside the try block, you could do the same thing. But
in this example, it throws something, but catch also catches this throw, catches this exception, not the main function. It keeps on the same function.
this one throws exactly the same exception that it code. But if you like to throw a new exception, then you would do something like line 17 in between line 21 and 23, right? So you will make a new exception and you will throw it.
All right.
You catch one exception and you throw another one, if you like.
Okay.
Okay. Maybe if I show you what happens after I run this throw exception function, it will be clearer. Okay. So if I call this function, first line 16 will be executed. It will write function throw exception throws an exception. And when I throw this exception, control will be here. And line 21 will be executed. Exception handled in function throw exception. And line 22, exception throw exception throws rethrows exception. And I will throw it. Okay. So this will terminate my function throw exception. This line 23 will terminate my function at 11, okay? So I am terminating my function. Why? Because I am throwing it. So this line 26 will never be reached. Nobody is going to reach line 26 because after I quote my exception, I am terminating my program. By the way, let me go to this one. Okay. Some people think that when line 53 throws an exception, let's say get high score throws an exception file IO error. Line 54 is not executed. That exception will be caught by line 56. This will be printed out. Some people think that this is like a function call. After I do this, the control will go back to line 54. No, control will never come back to line 54. After this high score, get high scores function throws an exception, I will catch it like here or there. After I catch it and after I execute this line or that line, control will flow to line 64. Okay. After you throw an exception inside the try block, there is no going back. This is not a regular function call. Okay. So people think that exception, after the exception, the control will come back to line 54. No, that's not going to happen. Okay, so this one says that I am throwing an exception, it will be caught, and I am rethrowing it. So who's going to catch this exception? Who is going to catch the exception thrown by line 23? That was a question. Another catch block. What do you mean, Hussein? Hussein, what do you mean by another catch block? I don't see any catch blocks here. If we add one more, it can catch it. No, we don't do that. What is the meaning of, I mean, don't change my code. I am not going to add anything, and that's not a useful thing. I mean, why would I throw an exception and in the same function catch it? Okay, Darwish Ali says that same catch block that we inside. No. I mean, okay. Hussein Ömer Güray says that nobody will catch it. Kamil said that it will be called by the function where it calls a throw exception. Yeah, who called this throw exception? Who called this throw exception? Okay, whoever calls this throw exception should be prepared to catch this exception, because this function throw exception, can throw, okay, an exception. That's why its name is throw exception. Let's look at the main function. Main function says that, okay, try, try this one, print this out. Main invokes function throw exception. Throw exception, it will be called. Okay, I will print this line. Okay, I am going to put a check mark. Okay, this one will run. This one will run. Then I will go to this one here. This one will run. Then I will throw the exception. This one will run. This one will run. And it will throw the exception. When it throws the exception, this function is terminated. This one will not run. Okay, I will go back to this one. Since this one has thrown an exception, this one will not be executed, but this one will be executed now because I am catching that exception. How about line 43? Is line 43 executed? Is line 43 executed? Yes, it will be executed. It will be executed. Why? After this catch block ends, control will be here. Okay, control will be there. So this is the sample output of that. Of this program, the whole program. Okay, any questions so far? Again, like all the chapters that we covered so far, there are two main things to understand. The first is why we are doing this, why there are exceptions, okay? And we said that we are using exceptions for making our programs robust and fault tolerant, okay? And we are going to use the same mechanism in Java 2, okay? In Java 2, many programming languages use similar error handling techniques. That's the first part to understand why we need it, why we are using it. The second part is how we can do that in C++, okay? After I talked about it, now we started talking about how we are doing this stuff in C++, okay? So we are spending most of our time to understand how we are doing this stuff in C++. Okay, good. Let me move on. Okay. Usually we write for our functions like this. I say that my function, it will take parameters, it will return something, and I may throw one of these exceptions. That one, or that one. So far, we did not use this syntax at all. Okay, we didn't have it. So far, we did not use syntax at all. But it is possible. It is possible. It is possible with C++ 98 standard. Okay. It is possible with C++ 98 standard, but unfortunately or fortunately, this throw list is deprecated. Deprecated with C++ 11. C++ 11 says that don't use the throw lists. Okay, don't use the throw lists. I will support it for now, but later this support will be discontinued. Okay, so if you are using the C++ 98 compiler and this throw list is fine, but C++ 11 doesn't like it. So then the good thing is let's not use the throw list because we are using the C++ 11 compilers. When you use it, it will be fine. although it is deprecated, it is supported, but later we will run into problems when we use the later versions of C++, because they see this. Okay, there will be some problems during the runtime, and I'm going to talk about it in a few minutes. Okay. So what happens if this sum function throws an exception that is not in this list? Okay. If you throw an exception from this function, sum function, and that exception is not in this list, then your program will call this function unexpected, which is a standard function that will terminate your program. During the runtime, you will get this effect. Okay, during the runtime, you will get this effect. Sometimes, okay, let me write this simple main function. This main function just lets me throw 1 and return 0. If you compile and run this program, what will happen?
Because no catch, it will give error in runtime.
Yeah, in the runtime you will get an error message. What is the runtime error? I am sure you get this runtime error all the time, but you did not understand what's happening. Maybe unexpected error. No, you don't call it unexpected error. Unhandled exception. Do you remember this term? Unhandled exception. I found an unhandled exception. I code an unhandled exception. This is an unhandled exception. There is an exception, but nobody's catching it. Okay, there is an exception, but nobody's catching it. So this is what was happening. This happens when you call a function. Usually you call these functions. Inside a catch block. Let me do it more relevant, May. Remember the quotient function? If I call this quotient function with these parameters 1, 0, since I know that the quotient throws divide by 0 exception, I should call this in a try block, and I should have a catch block, appropriate catch block. I don't have it. So nobody is going to catch this exception. And during the runtime, my program is terminated by the operating system, by the compiler code. Okay. This is just the opposite. This unexpected is opposite. Okay. This one is throwing an exception, but it is not in the exception list. It's an exception, and I cannot catch it because it is not in the exception list. So the error happening with the unexpected and the unhandled exception are two different things. Okay. So and again, both of them are runtime errors. The compiler will not generate a compiler error if one of them happens. Unexpected exception or unhandled exception. These are both runtime errors. That's why we don't like them much. Especially we don't like if somebody throws an exception out of this sum function and it is not in the list. Compiler should help me, right? That's why they discontinued this behavior. They say that we don't like it. We don't like to see these kind of surprising exceptions during the runtime. Okay, So I am going to skip this one because I don't have much time. As I said, if you don't handle your exception, your program will be terminated. I will not talk about stack unwinding. Let's see this example. Function tree. Okay, it throws a runtime error exception. And I just say that somebody has called function tree, and it says there is a runtime error. Runtime error is a standard exception, C++ exception. And function 2 says that I am going to print this out, and I'm going to call function 3. That's it. Function 3 is just calling function. Function 2 is calling function 3, and function 1 is calling function 2. And the main function just calls function 1. So the main calls F1, F1 calls F2, F3 calls F3. Okay? As you see, main is doing save. It say that I am calling function 1 inside main. Okay, I am calling function 1 inside main, and if something happens, bad happens, if exception thrown, there is a catch block, because potentially function 1 can throw a runtime error. Where do you see the runtime error here? I don't see any runtime errors thrown by function 1, but function 2 can possibly throw an exception. Why? Because function 2 says so. It says that I can throw, if the situation is right, I can throw a runtime error. But I don't see it here, but it calls function 3, and function 3 can throw a runtime error. Here, function 3 throws a runtime error. When function 3 throws a runtime error, function 2 is supposed to catch it, but function 2 doesn't have a catch block or try block. So function 2 is terminated. Okay, this one at line 16, function 3 is terminated, and line 23, function 2 is terminated, and line 30, function 1 is terminated. And the control comes to here. This is called stack unwinding. Stack unwinding. Okay. It occurs when a thrown exception is not caught in a particular scope. If you don't catch it, whoever calls you is supposed to catch it. If that doesn't catch it, whoever calls it is supposed to catch it. If none of them happens, the main function should catch it. If the main function doesn't catch it, okay, then unhandled exception error will be printed out on the screen, and your program will be terminated. Okay. Any questions?
Teacher,
Yes.
if there is a block of code after function 2 called function 3 and function 3 throw a exception, are that block of code is work or not?
No. You mean here, right? There is
Yes.
a integer A7. This integer A7 will never be reached. This will never be executed, because function 3 is not returning regularly. It is returning by an exception, and I am not catching that exception, so function 2 will be terminated. Okay, at that line 24, let's say this is line 24, this will never be executed. Okay.
Okay.
I think we did an example like that in the previous code. Let me find the previous code here, right? Main. Yeah. See, this line 35, there is a throw exception. It throws an exception. When the exception is thrown out of this line 35, 36 is never executed. And similar stuff happens here. There is a throw at line 23. This line 26 will never be executed. It's the same thing. Okay. Good. So that's it for this stack unwinding example. So we call it stack unwinding, and when you unwind the stack, when you finish up with function 1, function 2, function 3, all local variables of the functions are destroyed. So if I have, let's say, a money object here, M1, with $10, in it, if I have a PF array integer A10, okay, when you throw this exception, this money will be destroyed. Its appropriate destructor will be called. When this function 3 throws something, this A will be deleted, will be destroyed appropriately. So the destructor will be called on this A. Again, when this function 1 is, when the function 2 throws, function 1 will be terminated appropriately, okay, properly. So there is no memory leak problem. That's why we call it's a stack unwinding. All the locals, all the local variables objects are properly destroyed. Okay. Good. Okay. Exceptions are very useful in the constructors. Why? Because constructors don't return anything, right? I mean, remember that bit set? Okay. Bit set 5 B127AB. When I do that, there should be an object named B and should be a bit set. But the constructor says that this parameter is not valid. So what is the constructor supposed to do? So constructors cannot return a negative value to show that there is an error with the parameters. Okay. So what is the constructor supposed to do? Of course, in this case, nice solution, it throws an exception. Okay. When it throws an exception, while the constructor is running, maybe it has allocated some space with the constructor, right? So that space allocation will be returned back, and that kind of bookkeeping jobs will be done properly for the constructors and destructors. Okay, because there might be some dynamic stuff happening inside the constructor. When the constructor throws, you need to give back that dynamically allocated space. Okay, otherwise there will be memory leak every time there is a throw happening. Okay, so this is what it says. So inheritance with exception classes. Okay, I think I already showed that. Okay, let me show you this naive failures. Okay, naive, some compilers return 0 or null pointer. Some compilers throw a bad log. Okay, in this case, let's look at this. I'm going to take a few more minutes of your time. Sorry. I have a main function, very simple main function, a loop. Inside that loop, I have 50 pointers. For each pointer, I like to get dynamic memory of this size. How large is this? It's very large. It is very large, around 50 megabytes. Okay. So in 2006, it was a large memory. Okay. So around 50 megabytes. Around 50, exactly 50 million doubles. If I multiply it with 8, it's going to be 400 megabytes of memory. And if I do this 50 times, even with today's computers, I will be out of memory. So see, there is no delete operator called. So there is a intentional memory leak, right? So what I do here, I get a new space for 400 megabytes of data, and I say that since this pointer is not 0, my allocation is okay, and I do it again and again and again, and after a few iterations I will not get any space because this is too much space. So my pointer is going to be 0, then I will print this out and I will say that my new operator is not successful, and I will break out of the loop. So in this case, new returned a null pointer. But what did I say before? If I like, new can throw an exception. This is what you do. If you like your new to throw an exception, this is what you do. You include this header file, new header file, standard operator new. If you include the new header file, this new operator will not return a null pointer if there is no memory. Instead, it will throw an exception. That's why I do this loop in a try block. Inside the try block, I don't care about if new returns a null pointer or if the new operation is not successful. All I think is that this is my regular code. I will use the new and I will use the allocated space. If something goes wrong, it will throw an exception, bad alloc exception, and I will catch it inside my catch block, and I will do whatever I want. In this case, I will just print out an error message and I will finish my program. Okay, Mustafa. when Mustafa saw this slide number 50, he liked my slides or the other book slides, and he wants me to share it. Sure, I should do that. Exceptions. Well, okay. Okay, you got it? Okay, so this is what you do with the new operator. As you see, this is much cleaner code between line 21 and 24. This is much cleaner code than this code, because this code, every time I make a new, I need to check if it is successful or not. So I am intermixing the regular flow of control with the error handling code. I don't want that. That's difficult to read, that's difficult to write, but this is cleaner. Okay. In this part between 21 and 24, I concentrate on the regular flow of control, and here between 29 and 32, I concentrate on the error handling part. Okay. Good. I think I took too much time of yours. Sorry. I will stop here. Tomorrow morning, I will finish up with these exceptions. We will start our last chapter with the standard template library. After that, we will start talking about Java. Okay, good. I will see you tomorrow morning.